story really starts here with our core crypto system. It's a new type of encryption cipher or algorithm called XOTIC. And XOTIC has a special spelling to it because it's an acronym, which is XOR Transient Integrated Cipher. And this XOTIC cipher is very small. It's very portable. What you're looking at here is the Java rendition of it. We also have a rendition in C++. We also have one in FPGA directly for hardware, which could be burned onto an ASIC chip. But this version is multi-platform, and you'll see that in a moment. It's something that we can run directly from a command line, such as a DOS prompt, or programmatically. So if you were to have your own software, your own telecommunications platform, you could just add this library to your software, and in literally 2 lines of code, you're using XOTIC encryption. So that's what this demo is. It's building on top of what this encryption can do. So I'm going to start here with a little command prompt, and I'm on a Macintosh system here. I'll grab some sample content. So for sample content, I'll choose this one. This is some GoPro video. You can see it's a shot in high def. Actually, as I'm looking at it on my screen, it's very fluid, and as I'm looking at it on GoToMeeting on the other screen, it's a little choppy. We can blame GoToMeeting for that. In any case, you are looking at high def video content here. So I'll just move that into the directory for XOTIC. Is this large enough for everyone to see? Is anyone having difficulty with the size of what you're seeing?
It's fine with me.
Great.
Yeah, it's fine.
Okay, super. I'll try to keep the fonts large as I can. Okay, so here's how I'm going to invoke this program. I'll just use a standard command line, Java jar, invoke the jar, tell it to encrypt. Here's my scuba video. Now, XOTIC has a really unique property to it. This is very different than you're going to see with any other type of encryption cipher. You know, if you, for example, if you're looking at AES 256, it's always 256. XOTIC takes a parameter here, which is a number. It's a dial, like a dial on a stereo. And so dial 1 at the most basic level is 512, 512-bit encryption, twice as strong as AES. But every time I increase the strength, it doubles. So that's 1024, 2048, 4096, and so on and so forth. And so I can just send this parameter and change the encryption strength. And there's a lot we can do with that concept, especially when it comes into streaming video or media, because we can actually change the dial strength in real time. And that absolutely takes out an attack surface that other ciphers can't even approach. So I'm going to go ahead and choose dial 1 for now, and I'll encrypt my video here. And you see that happens pretty quickly. What's generated is a .exotic version of the file and a .xkf or exotic key file. Now, important to note here in this version of XOTIC, and we have another one that meets government compliance standards, which has a slight, some slight differences. But in this version of XOTIC, we are looking at literally 8 bytes on disk difference from the encrypted content versus the unencrypted content. And that's always 8 bytes. So if we encrypted a petabyte of data, a huge amount of data, you're still only adding 8 bytes. And that matters because at economies of scale, we don't want to encumber data with any kind of overhead. And so XOTIC doesn't encumber the data. The other thing you're seeing here is a symmetric encryption key. This is a key that was generated by the single operation or encrypting that file. It looks like this. You can see in its raw format, it's 8 64-bit random numbers. Now, these random numbers could be positive or negative. They're generated using a cryptographically secure RNG or source of entropy. For the hardware rendition, we actually have a laser diode that does quantum RNG, mathematically irreversible numbers. That actually serves as part of the encryption strength calculation, the metric that goes into cryptanalysis of this algorithm. So that's one way to look at it. You've got a key file, you've got You've got a ciphertext file, but we understood that people want something familiar, something recognizable, something that they can understand. So if I go over to my Windows machine here, which is linked up to the Mac, it's my 2 files I just created. You can see that when I moved them to the Windows machine, they got icons. And the reason for that is we created a shell integrated program that's exactly like WinZip. Simple as can be. Double click the file and decrypt it. And voila, there's my scuba video again on an entirely different platform. By the way, this Windows version is written in C++, and you know, we were inspired by WinZip for this. So if you right click on a file or a folder, you just see this zip crypt logo here, and it gives you the ability to encrypt as XOTIC. Right click, encrypt. We put AES in there for good measure so people could see how much worse and slower and weaker it is by comparison. But what's interesting about this is if you go to the settings, so I'm right clicking my buddy here with his fish, is you can actually visualize that dial. So in the graphical representation of this, if I dial up, it's a little more compelling than just typing the number in the screen as I did before. You can see I can turn this up to an astounding 131,000-bit encryption, which we have had cryptanalysis done by multiple researchers in multiple universities reinforcing that fact. So if I turn it up and I go to dial 9, let's just say I encrypt my friend here at dial 9. That was pretty fast. There's a little bit of a slowdown as you dial up. What we found in our testing, by the way, is that streaming media can be dialed up to about 6 or 7, depending on the platform, before it starts to get a little choppy. But here's the real impactful difference. So you see, once again, I've encrypted this file, but I did it at dial 9. So let's look at what that key is. Folks on the phone, those are a lot of really hard to guess numbers. If you think, you know, you can win the American Powerball lottery by guessing 5 really small numbers, try to guess these. So this is what we're saying. That's the impact statement of dial 9. And by the way, once again, the actual ciphertext itself is 8 bytes different than the original. So the ciphertext is not impacted by the dial at all. So you know, in packaging this as a consumer type of application, that's one thing. We created an email application. We created an online sort of encrypt file as a service application. But when we realized how fast, that's already open. When we realized how fast XOTIC is, we realized that this could be used for encrypting video frames differently. So, see, right now, if you're encrypting video, and I'm saying this to thwart pirates, by the way, if you're encrypting video, you're using technology like SSL/TLS. There are those out there that say that can be broken or hacked or man-in-the-middle attacked. And the reason for that is because really in TLS, you're guarding the transmission, but what goes into the straw and what comes out of the straw are still clear text. So even if you're guarding the transmission, and that's all fine and good, and we use it too, you're not encrypting the data itself. And here's a really good reason for that. If you consider AES 256, the current world standard in encryption, AES will boast that it has hardware acceleration these days on most Intel CPUs. And so, you know, that's true. And in fact, in file-based encryption, that starts to give it a real advantage as the file size increases. What we did here, what you're looking at here in this spreadsheet, is a comparative analysis of encrypting starting from 32 kilobytes files, just text files, all the way up to very large text files. And then we've got the time in milliseconds here for each encryption. And XOTIC at its dial 1 at 512, it's taking about 1 millisecond, 1 to 2 milliseconds on average. And this is actually, these particular numbers are from my Mac. We've done this on dozens of machines, and we've actually pushed it out externally to have folks test it outside of these walls. But what you'll notice here is this striking difference in AES. So if you're at 130 milliseconds and you try to encrypt one frame of video, well, you're getting 7.6 frames per second. That's sort of like an old 1930s, silent movie. Not good for high def. Whereas, an XOTIC at one, and this is an old Macintosh, by the way. If you're at 1 millisecond, I could get up to 1,000 frames per second. Consider the difference. And that's because when you're looking at streaming media, we're not sending large 16 gigabyte files. That's more of an archival use case. When you're talking about streaming media and what you're going to see in the demo here just in a moment, we're using a very high def camera that the FBI gave us, and that's about 1 megabyte per frame at HT. With 264-bit H.264 encoding and other encoding, we're seeing frames down to like 256K per frame in a high def video stream. And so that really sets us apart in a use case from AES, because at the low end of data, XOTIC is 99% faster than AES. So that's the takeaway here. Okay, so now we have a real challenge to overcome, and this is our next patent, which is how do we get that XKF file, the one you just saw, if we're making a bunch of these for every frame, how do we get that from the sender to the receiver? How do we get that from Alice to Bob?
And Alice or Bob is person or hardware device.
Right. So here's what you're about to see next. Let me pull this up here. This is a nice way to visualize it. We created a series of cloud-based servers in every different region that Amazon Web Services offers cloud-based services. And these are really small services. They have 4 gigs of RAM, not a lot of disk. They don't have to be very powerful at all, because the purpose of these servers and all these locations is simply to act like a radio repeater. If I'm taking a camera, which you're going to see here in a minute, we have a dome-style camera set up in the office here, and you're encrypting the stream out of the camera to the viewport, and every frame is being encrypted. We need to transmit that XKF file from the sender to the receiver, and we're using this mesh network of cloud services to fragment the key into little pieces and get that back to the authenticated receiver. That's very different than TLS. It's a non-PKI type of key exchange. So what happens is the camera starts streaming and the viewport just sees static. You're actually going to see what the real time. If you pump encrypted data through a viewport, we're going to show you that in a minute, what it actually looks like. And we are using for this transaction a media server and a SIP server, kind of like voice over IP does a handshake to connect these. And the reason for that is, in a real world scenario, you have many cameras and many viewports, or many sources of data and many consumers. The media server, whether it's live telecast or on demand, is a pub sub, publisher subscriber kind of a pattern. So we followed a pretty standard protocol for that. And oops, I went a little fast there. And so what happens here, and I'm also going to show you a live look at our servers. So when the camera starts breaking keys, it's going to send pieces of key fragments somewhere random. Let's say randomly, in this case, it chose Virginia and Tokyo. And then Virginia and Tokyo, in turn, pick other random locations and re-forward those keys elsewhere and then clear themselves of memory. As acknowledgement happens, the keys are recovered by the viewport and the static becomes clear. And the key material only exists for a few moments on the mesh network. This is very scalable. It can be hardware. It can be local area network, as Richard opened the conversation. We're deploying this in an embassy. Amazon Web Services have no room in that environment. But the pattern itself is very, very scalable in terms of breaking a key, picking random repeaters, and using that mesh network.
Michael, let me put for a moment. Ali, do you have any quick questions? Because I know you got 7 minutes before you have to bail out. Any quick questions before Michael shows us the cameras?
Excuse me. How does this apply to live linear channels. This is file-based encryption. But do you have a product or something that encrypts on the fly, you know, live TV?
So I'm going to start my application here, and I'm going to start a Dome camera application on the camera, and it is now streaming encrypted data, which is coming across as static because it's doing the key exchange that you just saw in real time. It's randomly chosen Paris and Sydney, Australia to transmit. The first key takes a little bit of time to traverse. After that, it's seamless. The key is acquired. I now have a signal. So what you're looking at here, if I go to my local network on the right, is real-time view of our office. What you're looking at on the left is actually 512-bit encryption per frame in streaming video with almost no lag. My friend put up a little screen so you can't see what he's working on here. But you can see there's no lag. Now I'm going to move the screen over so you can see this key exchange is still happening, by the way. You see it just said Frankfurt and Mumbai. If I go over to this terminal here, you can see that the pieces of key, these are actually Unix terminals, are moving around as it goes through its next cycle. You'll see it shuffle in green here. We'll give it a second. There was one. There was one. So what you're actually seeing is pieces of key moving around the world in a way that from real-time streaming video does not interfere with the video quality at all. Oops, let me show you something better. Let's zoom in and see how tight we can zoom. Where this video, so it's not file-based. This is streaming media-based and
live in real time.
You're looking at live real-time feed, and the idea here is that you're not losing any kind of quality. And unlike TLS, by the way, if you get an SSL certificate, if you're doing it right, you're probably renewing it once per year. Okay, so this has sent keys while we've been talking. 1, 2, 3, 4, 5, 6, 5 times.
So like quantum resilient strength.
So you're at 512-bit here, and what's interesting is we can change the dial setting in real time on the. I'll find my camera here. On the stream. So each packet don't know what size it is.
Thank you.
Sorry.
Go ahead.
Increase the dial, Michael, please, just so at least we can compare it. Yeah.
I can't do that manually. The demo's not configured for me to show that.
Okay, fair enough.
Okay, so this is the main point of the demo, to exhibit how we could use this on streaming media. We are also applying this to, right now, we're going to Aberdeen Proving Grounds in Maryland to show them how we can use this with secure military walkie-talkie type devices with a 15-kilometer range, and multicast, where you can choose which party gets to see which piece of data. So if I were at a conference room table and I spoke into the walkie-talkie and the police shoulder mic, I could choose who's hearing my voice and who's hearing static. And so the same really applies whether it's streaming audio, voice over IP, or streaming video like you're seeing here. The main takeaway is this encryption is stronger and fast enough to do it differently without impacting the quality.
Eli, does that answer your question?
Yes, yes, it does. Do you guys have any deployments in the media sector now? Or do you have any customers that you?
We are working with Limelight Networks actually on multiple different projects in live streaming with some of the things they're doing, including video on demand. We also actually have one of their I guess you call it camera with the doorbell, kind of like Ring, but it's another supplier that is using those live cameras that are, very security sensitive to that, because it's not just for homes, it's also buildings. So that's really what we're looking at. This is has been newly packaged per the requirements of access cameras and the subcontractor to the U.S. State Department. And we're now showing it to bring out, and it's now extensible to all the different environments that Michael just stated. So this is fairly fresh, but it's been highly tested now already in multiple different ways and means.
Okay.
Okay.
Okay, so just being sensitive to time, this is where the demo ends. We're coming up on, quarter to the hour here. Just ready to take any other questions as you have them, and we're leaving it on the screen here with skiffcom.com, which is our website for XOTIC, where you can actually download a trial version of the software. It has some documentation and some performance statistics right there online, as well as the ZipCrypt utility and the secure email.
No, I think this has been very, very helpful. Before you go, do you have any other last any quick questions before? I mean, once you leave, the guys and I will continue a brief chat.
Yeah, I apologize, but I have a very important call coming up, and I just wanted to prepare for it for a few minutes. What I'll do is I'll share this with our CEO, who is the technical brains behind our operation, and see how, I'll let him sort of evaluate how this can fit into what we're doing. I'm sure we have some kind of encryption. I really don't know what protocol we use and all that stuff.
Sorry, I'm sorry to interrupt. I just want, for efficiency of time, to bring up a data point that is very important for that region you're speaking of, the MENA region. We've been running a AdWords campaign through Google for 3 months now on a very, very low budget. That's $15 a day for the one Windows product, ZipCrypt, that Michael exhibited earlier. And the results of that are overwhelmingly and very specific. There has been a 300% increase to our web traffic, to our main website and to Skiffcom. The ZipCrypt product in its trial setting is a loss leader to lead users to sign up for Skiffcom services. A significant majority are coming out of the Middle East, Saudi Arabia, Dubai, and Morocco, Egypt, Turkey, all those regions, and a significant majority of those are coming off of Android devices. So we have it on our roadmap. We have about a 70% completion of that platform. It's part of the reason why we're raising funds, is to finish that. But there is no question, no denying that encryption keyword searches are showing significant interest from MENA region for higher levels of encryption. So while I understand you have encryption or might have encryption, there seems to be interest for something beyond the world standard.
Right.
That's very interesting.
Very good point. Thanks for sharing. And besides, as you probably know, Richard, my interest in all this is not necessarily just the MENA region, but it's sort of like international or global. Sure. Certain regions do provide different opportunities from other regions, but from what I see, I think many different stakeholders from different levels and different sectors, including at government, will have need for this service in one format or another.
Correct. Thank you.
Okay. Eli, if you need to break away, that's cool.
I need to back off. I really appreciate it. If you can please email me the recording so that I can share with my people, and we'll figure out what the next step is. I will keep the communication going. We're pretty tied up all of next week with a trade show in France, but I'll try to keep it going in a timely manner.
No problem. No problem, Eli. Keep me posted.
Okay, I will. Thank you, gentlemen. Thank you very much. Have a great day.
Thank you very much.